Do you remember what all we learned in the last class?
Yeah, we learned about area of composite shape.
Okay. So let's do few sums with composite shapes. And we don't have to do the sum. I just want to hear the approach from you. But
Okay.
before we do that, did you do the homework?
Yeah, I think so. I think I finished it.
You finished it. Did you show it to your parents?
Not yet. You
That's,
there?
I'm sorry.
I didn't show it yet.
Yeah. So that's a very important part of our learning experience. Okay.
Okay.
I would request you to make sure that every homework we do, I know parents always busy with a lot of things, but catch hold of them, spend 15 minutes with them, say, okay, I'll just show you two of the sums that I have done, and I'll explain you how I have done.
Okay.
Say that because my teacher will not accept this assignment unless my parents sign it. Okay.
Okay.
So when you show it to them, explain them with patience that okay, this is what I have learned, this is the question. Based on the question, this is what I understood, this is my approach, and this is how I have solved it. If you explain that, trust me, your parents will hug you. They will like it. Okay?
Okay.
Because what happens is when we learn something, most of the times we assume that we have learned,
Okay.
but we may or may not have learned. Okay? So when you explain that same concept to somebody, okay, that is
Hmm.
when you realize that okay, did I learn it enough, did I learn it well, or did I not? Okay, so that
Okay.
showing that homework to your parents is actually an attempt from by us, by you and me, to make sure that we have actually I'm able to teach you well and you are able to learn it well. Okay, so that is
Okay.
a very important exercise. Okay,
Hmm.
all right. So we learned about composite shapes. So let me share my screen, and you will not tell me the answer. You will just tell me how will you derive it. Okay.
Okay.
Let me know once you're able to see the screen. Can you see my screen?
Yeah.
Okay. Now I will have to explain some of the things because no, my drawing skills are not great. So this is a semicircle. Okay. This is a
Okay. Is that a trapezoid above?
yes, that is a trapezoid. So this is 3 centimeters. This is 6 centimeters, and the perpendicular distance between the two is, let's say, 7 centimeters. Here, the radius is, I'm not telling you the radius, okay? You tell me the area of this. Okay, 1 second, let me draw it properly. So, this is a semicircle. Ah, you don't laugh, okay? My drawing skills are very bad. Uh-huh. So, I said this is a semicircle, this is the center. I
Okay.
said this is 3 centimeters, and the perpendicular distance between the two lines is 7 centimeters, and this side is 6 centimeters. Okay, now you tell me the area of this composite shape. How will you find it out? Think about it and let me know.
Hmm. I know how to solve it.
Okay, you just tell me the approach, like you're explaining me, like you're explaining to a baby. Okay, I'm a fifth grader, you explain me how would you want me to do it? Okay.
So to find the area of this entire shape, first you need to find the area of the trapezoid. Then you need to find the area of the semicircle, and then add them together, and then you'll get your final answer. So how to do that is that the trapezoid. I know that the trapezoid formula equals to base 1 plus base 2 divided. No, no, no. Base 1 plus base 2 times the height divide by 2.
Mhm.
So for that, so I did 6 plus 3, which is 9 times 7, which equals to 63. And I've divided it by 2, which probably gives me
Okay, that
31.5
uh-huh. Okay, 31.5 what?
centimeters square.
Okay, yeah. Okay.
And
So
for
that
the semicircle,
mhm.
I know that my formula for the semicircle of the area equals to pi times r radius squared divided by 2.
Mhm.
So the entire hmm, the entire thing is like 6, so half of 6 is 3.
So stop there. Okay. That was the trick I was trying to apply here. I was trying to get you confused by not telling you that this is a diameter. I said, okay, the trapezoid, one line is 3 centimeters, second line is 6 centimeters. So when you looked at it, you told me that this is 6 centimeter. The area, the radius will be 6/2. That is what I was waiting to hear from you, and you did it right. Good job. Okay, yeah, go ahead.
So I'm doing correctly.
Yes, 100%.
Okay. And then after you do that, you do pi 20,
R is your how much?
r is radius squared, so it's 3 squared, so 3.14 times 3 squared equal, so that would be 3.1 times 9. What's 3.14 times
Okay,
0.14 times 9 would equal to 28.26, and if you divide by 2, I think it will probably give you 14.13.
14.13. Yeah, you're right.
Mm-hmm.
Okay, so good job, Mitran. Okay, so that is what I don't really care whether it's 14.13 or 14.19 or 16.12. I hardly bother about the answer. Okay, because answer is something that I can derive.
Mm-hmm.
Concept is something that we learn. So
Okay.
if we are clear with the concept, math becomes like a cakewalk. That's what happened here in your case. You knew that composite shape means combination of few shapes. So as soon as you looked at this one, you say, "Oh, this is my trapezoid. This is my semicircle." I know the area, how to derive the area of a trapezoid? Yes, I know. It's half times the height times both the parallel lines, length of parallel lines.
Mm-hmm.
And then this is semicircle. This is half of a circle. So half of the area of a circle. Now,
Okay.
do I know what is radius here for the semicircle? Yes, I don't know the radius, but I knew this is the semicircle and this length is known. So I know the diameter, and my radius is always half of the diameter. So if this is 6, this is going to be 3. And now
Mm-hmm.
it's a calculation. Math, see, I will not doubt no, a grown up kid or a senior kid like you to be wrong with the maths. If you're doing pi r square, I would not worry about whether whether no you're doing this calculation right or not. I would worry
Uh,
about how are you finding this value and then putting it in the equation. Once you put that in the equation, I'm not assuming even that you will go wrong, right? Because that is what will come
Okay.
across. I'm sorry.
Okay.
So I will always focus on making sure that your approach, your concept doesn't go wrong. Okay.
Okay.
Now, let's do one more sum, and then we'll learn some of the basics of no, three-dimensional shapes. Okay.
Okay.
So basically, we are going to spend another maybe three or four more, three classes, maybe more, to cover all the geometry that we need to know as part of uh, SAT. Okay.
Okay.
So everything that you need to know as part of geometry till SAT will cover, except the graphs and all. Okay, graphs and those things we'll learn in the subsequent classes. But yeah, the basic shapes, the volume, area, perimeter thing, that we should not have any doubt about. Okay.
Okay.
All right. So let's look at. I also don't know what kind of shape it is. Okay.
Okay.
I just, to me, this line and this line are parallel. Okay.
Okay.
And I know the distance between from here to here, the perpendicular distance between the two lines. I know that. Okay.
Hmm.
Or let me. Okay. Yeah. So this is a shape. This line and this line are parallel. I know the perpendicular distance between two lines, and I know the if I draw this line here, okay, I know the distance between these two lines, the perpendicular distance. Let's say this is 3 centimeter, this is 6 centimeter. Okay, this is 8 centimeter, this is 12 centimeter. Okay,
Okay.
now you think about this equation, this problem, and tell me how will you solve it. And this is not perpendicular. Okay, this is a slanted line. Okay,
Hmm.
did you get it?
I'm still. So is this like a pentagon, but the line is slanted on the bottom?
It is a pentagon because obviously you have five sides, so this is a pentagon. But
Mm-hmm.
yeah, I did not say that this is not a perpendicular line. So this is not 90 degree. Okay,
Okay.
but I have told you the perpendicular distance between this line and this line is 6 centimeter,
Mm-hmm.
and this point, the perpendicular distance between this line here to here, it is 3 centimeters. That's what I've told.
Okay.
And this line are parallel. That you know already.
Okay.
Okay.
Um,
Uh,
I think I can't tell.
you can tell or you can't tell.
I can't.
Okay. Tell me what you can tell and what you can't tell.
I divided the shape. I actually divided the shape into a triangle and a square. But since you told me that's not 90 degrees, I thought it was like a trapezoid. So I thought it was a trapezoid, so I did the trapezoid formula, which I got 60 for that trapezoid. For the triangle, I found the base for the triangle, but I can't find it for the height. I can't find the height.
Okay. So here, I'll tell you, this is not the right question actually, but you are going the right direction. Now, what you can do here is, see, we only know the this height here to here, right? And I
Yeah.
also told this is the perpendicular distance. So you know the perpendicular distance between this line and this line. Okay, that is 3
Okay.
centimeter. If from here to here is 6 centimeter, that means this line is also 3 centimeter from here to here. Yeah. Now
Mhm.
you can look at this shape as two trapezoids. This is one trapezoid
Mhm.
and this is another trapezoid.
Okay.
Do you agree?
Yeah.
Right?
Yes.
Now the only problem here is, if you want to find out the area of a trapezoid, you need the length of the two parallel lines, this one, and the height.
Okay.
This one you know, this one I did not tell, right? Similarly, if you look at this trapezoid, this length you knew, this one I did not tell.
Mhm.
So, what was missing in this question was the length from here to here.
Okay.
If you would have known this length, then it was very easy for you to find out the area of this trapezoid because you knew the length, the height between the two lines, and you knew this one and this one. Similarly, in this trapezoid, the one at the bottom, you knew this length, you knew the height because you could derive that 6 minus 3 is 3. You knew this. Only thing you did not know was this center line. If you knew the length of this line, you would have
Uh,
found the area for this trapezoid, you would have found the area for this trapezoid, and you would have added them together. Okay?
Oh, okay.
Yeah. So, so see, not every question is meant for solving. Okay? The question is kind of
Okay.
triggering the thought process to find out what my approach would be, what I need to know for solving a problem, what I already know, and what information can be derived or cannot be derived. Okay,
Okay.
so that is why the first step from formula, the TRAN formula, I say, right? Trust, read, analyze, and Nike. So
Okay.
so so that is when you're reading the question again and again, and you're drawing the picture, and then you're analyzing, okay, now I can break this into two trapezoids. Okay, if I break
Sure.
into trapezoid, what do I need to find the area? Okay, I know I need the length of the two parallel lines and I need the height between them. Do I have that information? Okay, I know one of the side, I don't know the second side. I know
Mhm.
the height, I know one side, I don't know second side for the second one also. So what is missing is the middle line, the length of the middle line.
Mhm.
Then there's one more step that you can think, okay, if I that number, that length of the line is not given, is that information hidden somewhere? Can I derive it? If you are able to derive it, then I will derive it and use it. If I'm
Mhm.
not able to derive it, that means the question is not complete for me. I will ask for
Oh,
information, right?
okay.
I would have given you 100 out of 100 for this question if you would have challenged me saying that, okay, if I break this down, see, the question is not always correct. Okay, questions could be wrong at times. That is where your concept plays a very, very important role. Okay,
Okay.
so you can always read the question, analyze it. Don't start doing it till you are convinced that you have all the information, you know how to do it. Okay,
Okay.
so that should be a approach. That's what I keep emphasizing on. Okay, so
Mhm.
more and more focus on more and more focus on no, uh, what do you call the concept? More and more focus on kind of relating your concepts with the question before you attempt to solve the question. Okay.
Okay.
Yeah. So we learned about this thing. We learned about the composite shapes. You know how to break them into simple shapes, then relate that with the formulas and all, right? So I will not go there. Only thing I would want you to do is the assignment that I have given you. Show it to your parents. Explain them. Okay. Te- Visualize that they are like the babies. Okay, they don't know it. You're trying to teach them. Okay, that is how you should try explaining it. That this question is about this requires me to do this is what I know, this is how I relate, and this is my approach for solving it. If you tell
Uh,
the story in a very structured way with patience, trust me, they'll love it. Okay.
Oh, okay. Okay.
All right. Now let's look beyond the two-dimensional shapes. When I say two-dimensional shapes, meaning something that we can draw on a piece of paper. Okay,
Okay. By the way, can I get a glass of water? My throat's a little bit dried.
100%. Go ahead. I'm thinking what as well.
Back.
All right. So far we were dealing with things that we can draw on a piece of paper, right? We were dealing
Mm-hmm.
with things that we can draw on a piece of paper. Yeah, that's what I'm doing right now. I'm drawing it on the screen, which is as good as a piece of paper. Yeah.
Mm-hmm.
What about this guy? Can I draw it on a piece of paper?
No.
No, because this is something more like a solid. I mean, I can make attempt to draw a three-dimensional shape like a matchbox. Okay, I can
Okay.
draw it. It gives the illusion that it's a three-dimensional shape. Yeah, it looks like a matchbox or a brick. I can, if I have good drawing skills, I can still draw this guy. I mean, I don't think my drawing skills are that great, but yeah, I can draw this guy, and it might look like this. But then that is not the purpose. What I'm trying to say is we are talking about things which is
Mm-hmm.
beyond this and this direction. When I'm looking at a piece of paper, I'm looking at one side like this and another side like this, which I call as length and width, right? Or
Okay.
in future you will start calling it as x-axis and y-axis. Yeah,
Mm-hmm. Okay.
right? So any piece of paper that we look at, any sheet, it's a two-dimensional thing. It has a length and a width.
Mm-hmm.
Yeah. And all the shapes like circle, rectangle, square, trapezoid, whatnot, rhombus, everything can be drawn on that. But when we start dealing with a solid shape, something new has to be learned. When we were looking at this kind of a shape, we were looking at the area, the space that it takes on the piece of paper. Yeah.
Okay.
This takes more than space, right? Because it has
Mm-hmm.
height. It has a base which is like an area of a circle, but it has
Okay.
also it takes space in the space. No, it takes space in the air. Okay, right?
Yeah.
That is called volume. The total space that any solid shape takes or uses is called volume. This uses more volume. This uses less volume.
Okay.
This uses different volume. I use more volume. Yeah, yeah.
Mhm.
So,
Mhm.
what is volume here? If you dip these objects in water, this will displace the same amount of water of its size. Meaning, if you have a glass, if this glass is full, I mean this tumbler is full, okay, with water, okay, then I
Okay.
drop this air pod inside that, it will displace the water, the amount of water, which will be same as the volume of this guy actually, because
Okay.
this guy is trying to create a space for it living inside this. Okay,
Mhm.
so let's say on a bed, if there are three people lying on the bed, okay, the bed has only enough space for three people. If the fourth person has to come in there, one person has to be displaced, right, or thrown out of the bed, right?
Mhm.
Same way, if this is full and then I'm trying to drop this guy inside this guy will need space to settle down or to, you know, stay inside. So it has to
Okay.
displace same amount of water to create enough space for itself. Yeah.
Mhm.
So volume is nothing but the total a total space taken by any object. Okay. Now let's
Okay.
look at this. If I'm talking about a cylinder, okay, it's like a circle. You're putting another circle, another circle, another circle. Keep on putting circle after circle. That makes it look like a cylinder. You would have seen the toys, right? Like the bangle toy. If
Yeah.
you
Yeah. I remember seeing one of those when I was younger.
yeah. So the cylinders are made with those things. Now you see this other example. I'm going to keep on talking till I'm confident that you understood it. Okay. So now
Okay.
you look at this. This is a rectangle. Yeah.
Mhm.
Every piece of paper is a rectangle.
Okay.
What is happening here? There are rectangles kept one after another. Yeah.
Mhm.
There are more and more pages kept one after another. That is what is adding height to this notebook. I have, let's say, 50 pages right now. That's why the height is this much. If I had 500 pages, the height would have been this much. If I had 1,000 pages, the height would have been even this much, right?
Okay.
So, what is changing here between this rectangle and this notebook is the height.
Yeah. The
So,
height speed. The height's increasing.
yeah. So, my area, if I'm adding area after area after area after area after area, that is what is adding height here. Now
Okay.
you look at this tumbler. Okay, if you look at it from this side, this is a circle. There are
Mhm.
so many circles kept one after another. Okay, from here till here.
Mhm.
Imagine these are like those small rings after no kept one on the top of each other.
Mhm.
That is what so many circles together is building this height. Now imagine a house where we live, right? Every
Okay.
house you have brick, another brick, another brick, another brick, another brick. More the bricks, more the height. But all the
Okay.
bricks are same. All the bricks are same dimension. You're just adding more and more to increase the height, right?
Yeah.
So if there's a much taller house, there are more bricks, more height. So is the thing here. So now let's look at this. How much will be the volume of this cylinder is a function of how big is this circle, meaning how big is the diameter, and then how tall it is. Yeah,
Mhm.
right?
Okay. Yeah.
So you find out the area of this guy, the base, the cross section, or this one. What is that is pi r square, right?
Oh. Okay. Yeah.
and then you multiply that with the height of the cylinder. This is your volume.
Okay.
Area after area after area after area. More the and so area remains the same. What is changing here is the height, the number of rings you're adding here, right? That
Mm-hmm.
number of rings is h, height. How many you have added?
Mm-hmm.
Yeah.
Yeah.
So volume of a cylinder. You learned one formula just by relating or visualizing the shape. Okay.
Mm-hmm.
Volume of a cylinder is pi r square times the height,
Mm-hmm.
meaning the area times height. Area times height is what we will remember. Now look at this shape. Do you know what is this called?
A rectangular prism.
Rectangular prism, or you can call it a cuboid.
Okay.
Okay. So a cuboid or a rectangular prism is nothing but a rectangle. This is length and this is the width of the rectangle.
Mm-hmm.
So many rectangles of the same shape, same dimension, put one after another to make it taller. Okay.
Okay.
This is the height. Same formula you'll apply. Area multiplied by how much height you have added here. That becomes your volume.
Okay.
So this will be length times width times height. Taller this one, more the volume. Smaller this one, less the volume. Yeah.
Yeah.
So you learned the second formula. So one was the volume of a cylinder was pi r square h,
Mm-hmm.
where r is the radius and h is the height of the cylinder.
Mm-hmm.
Yeah.
Yeah.
You
Yes.
learned the volume of a cuboid. Okay. This is
Okay.
length, this is width, and this is height. You said, okay, same thing. Area of the base is length into width. I will multiply this with this is volume. Okay.
Mm-hmm.
I will multiply the area with the height of the this prism. Okay.
Mm-hmm.
Area into height. So that is length times width times height. That is my volume of a cuboid or a rectangular prism. Okay.
Okay.
Now think of a third shape. Have you ever eaten the ice cube from the fridge?
Ice cube. No.
No? Okay. Don't do it. but yeah, every kid does.
But
Like,
some of my friends do, and even the teachers eat ice cubes.
yeah. So ice cubes are called cubes for a reason, actually. Okay. Cubes is a geometrical term, which means a shape with same length, width, and height.
Mm-hmm.
Imagine a square. Okay, this is a square where length and width are same. Okay, and
Okay.
if you extend a height so much that this length, this width, and this height all are same, length
Okay.
equal to width equal to height, that is
Okay.
what is called cube. So the difference between a cuboid or a cube is the same as the difference between a rectangle and a square.
Mm-hmm.
Rectangle has length and width different. Square is another type of rectangle where length and width are same, right?
Mm-hmm.
Same way, cuboid and cube are the same or similar things. Only difference being here the length, width, and height all are same.
Mm-hmm.
It's like an extension of a square. Yeah.
Yeah.
And now coming back to the cube theory, the ice cube was given a name as ice cube because it's something which is 1 centimeter in length, 1 centimeter in width, and 1 centimeter in height. So
Mm-hmm.
an ice cube is actually a geometrical term which says a cube which is made of ice.
Okay.
And why cube? Because the length, width, and height of that is the same, 1 centimeter.
Okay.
So that is why it is named as ice cube. But nowadays in fridge you get different, no, what you call, different types of frames for making ice.
Yeah.
So I have seen ice cubes which look like elephant, baby elephant also. But that is not actually cube in the technical terms. We just use that term. But actually, if you're talking about an ice cube, that means an ice, a shape of ice which is like a cube where length, width, and height is 1 centimeter each. Okay.
Okay.
So in case of a cube also, which is nothing but a cuboid, only difference being length, width, and height are all same. So here also the volume will be the area, which will be length times width or length times length because all are same,
Yeah.
multiplied by height. And here the height is also same as length. So it becomes length cube, length times length times length. Okay.
Okay.
So we learned the volume of cuboid was length times width times height. For the cube also it will be the same, just that length, width, and height are all same. So that is why we don't say length times width times height. We say length times length. That
Uh,
is that is how
okay.
volume of a cuboid is derived. Okay.
Hmm.
So
Okay.
we learned about solid shapes such as right cylinder or cylinder. Cylinder is also called a right cylinder. I don't know why, but it's called right cylinder. Okay. Primarily because if you look at a cylinder, right, it's called right cylinder because this is straight. This is making 90-degree with the ground, okay, where it's standing.
Okay.
But they call it right cylinder because you can have cylinders like this also.
Hmm.
Yeah,
Yeah.
this is also cylindrical shape, but this is not making 90-degree with the ground. That's why they call it right cylinder. Is what I can relate. Okay,
Okay.
so we learned about what is a cylinder, what is the volume of a cylinder. We learn about what is a cuboid or a rectangular prism. What is how do we derive the volume of that? We
Hmm.
learn about cube. We also learn about ice cubes. How do you find the volume of a cube? That also we learned. Volume in simple terms is the space that it occupies in a
Okay.
in a in a three-dimensional setup. Yeah.
Yeah.
And why we call it three-dimensional? Because see, when we are looking at circles, we were looking at this direction, this direction. This was my page. But when I'm looking at a solid shape, I'm looking at the x and y side of it, the horizon, the length and width as well as the height. So length is one dimension, width is second dimension, and height is third dimension. Okay.
Okay.
So we are all everything that we see around us is actually three dimension, right? So I'm not sure if you have watched any 3D movies. Did you?
Huh?
Have you
Watch any
watched?
three?
Have you?
Yeah, I think I watched some 3D movies.
Right? Because they call it 3D primarily because if you go to a theater to watch a movie, what you're seeing is on a screen which has length and width, right?
Hmm.
But when you put a 3D glasses, what happens? It looks like something is coming out of the screen, and it'll make you feel like you are seeing an animal in front of you, or the things in front of you in its original shape. It
Okay.
doesn't look like it is on the screen always. Yeah.
Hmm.
So that is why it is called 3D. It gives you the three-dimensional view, length, width of the screen, as well as something coming out of the screen also as a height. Yeah.
Okay.
So that's how you can relate it with 3D. Okay. So we learned. Okay. I think my laptop is running out of battery now. Okay. So we learned about uh, right cylinder. We learned about cuboid. We learned about cube. I can teach more things, but I would probably pause it here. Let's spend some time doing tables, okay?
Okay.
Because if I pump in a lot of things, and you don't get time to practice, it'll get confusing actually. Yeah.
Okay.
Because in the 3D shapes, uh, if we do the sums and then learn a little bit more concepts, I think that should be enough for you to know what you need to know from a geometry point of view for SAT. And then we'll anyways, we still have a lot of time, right? So we can learn the things that we miss in the class. This is certainly a lot more than what you guys would have learned in eighth grade or till eighth grade in the class. Okay.
Okay.
So let me stop presenting my screen. But the video is still on, so you can stay off the video, but we'll do the tables quickly. Okay. So let's do a quick check of the table. Let's see how much we remember. Okay.
Okay.
So have you memorized the table of 13 as well now? 13.
I think so.
Okay. 13 6.
13, 65.
Now 13 6. 78.
65.
Now 13 5 are 65.
Yeah, 35 or 65.
13 6 are 78. Okay. Now 12 nines are
12 nines are 108.
wonderful. 9 sevens are
9 7 63.
okay. 8 eights are
It is 64.
okay. Uh 12 sevens are
12 sevens. 12 7 84.
84. Okay. 13 6 are
13 6 star 65.
now I purposefully repeated my
3.
78.
Oh.
Okay. So that means we have an opportunity for see. I see that your table thing is perfect up to nine table of nine.
Mhm,
12 and 13 is where we are taking a bit of time to recall. Yeah. And
mhm,
sometimes we are going wrong. So let's focus on table of 12 and 13. Okay. So
mhm.
let's do table of 12. Okay. You will sing, I will follow you. I will also repeat with you. Okay.
Okay.
So you teach me table of 12. Okay. You start from beginning. 12 ones are 12. You start from there.
12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48, 12 fives are 60, 12 six are 72, 12 sevens are 84, 12 nine, 12 eights are 84, 12 nines are
You went wrong. So keep 2 seconds or 1 second pause. Okay. Start from beginning.
12 ones are
Yeah.
12, 12
12
twos
twos
are
are
24,
20,
12
12,
threes are 36, 12
12,
fours are
12,
48,
12.
12 fives are 60, 12 six are 72, 12 sevens are 84, 12 eights are 96, 12
Yes.
nines are 108, and 12 tens
And
are
that one.
120.
So basically, when you were rushing for it, I heard you going wrong between 12 sevens and 12 eights actually. So that's why I asked you to go a little slow. Okay. All right. Let's start with 13.
13 ones are 13, 13 twos are 26, 13 threes are 39, 13 fours are 52, 13 fives are 65, 13 sixes are 78,
7 ja,
13 sevens are
91,
91, 13
8.
eights are 104, 13 nines are 117, and 13 tens are 130.
Okay. I want you to master up to 13 before the next Saturday. I'm not saying tomorrow. Uh, before the class on next Saturday, the target should be that 12 and 13 should be like a cakewalk for me. Okay. That should be a target. All right.
Okay.
How will you do that? Only 5 minutes every day. Whenever you are not doing anything, just sitting in a corner, 12 1 is 12, 12 is 24, 12 3 is 36, 12 4 is 48, 12 5 is 60, 12 6 is 72, 12 7 is 84, 12 is 96, 12 9 is 108, 12 10 is 120. Oh, less than a minute. 13 1 is 13, 13 2 is 30, 26, 13 3 is 39, 13 4 is 52. You'll do it, and wherever you get stuck, start from the beginning. Let's say you got stuck at 13 5 is 65. Okay, you said something else, or 13 6 is 78. Oh, 13 6 is 78, 13 6 is 78, 13 6 is 78, 13 6 is 78. Okay, I remember it now. 30,
Mm-hmm.
we'll start from beginning. 13 1 is 13, 13 2 is 26, complete till that. All this exercise will not take more than 5 minutes, trust me.
Okay.
But it has to be like this. In the next class, when I say 12 6, you'll say 72. Even you will not take a fraction of second. It should come out naturally. Okay.
Mm-hmm.
Something like your muscle memory. Okay.
Okay.
That is the desired state we want to get to with
Mm-hmm.
tables. Because if that happens, you will see the magic happening in your maths. We do a lot of sums. Okay. We we need to write on the piece of paper while solving it, but if we do a lot of mind maths, it increases our speed and accuracy for solving the sums actually. Okay, so
Okay.
that is why tables are very very important. Tables enable us to become much more proficient and effective with our maths actually. Okay,
Okay.
so with that being said, I will stop recording the video so that you can turn on your video